Well, welcome to the Fastener Training Minute, brought to you by the Fastener Training Institute and AIM Testing Laboratory here in beautiful El Cajon, California. It's a stunningly beautiful day here in San Diego, and it's kind of a nutty time right now. It's nuts. Everybody's nuts. The world's gone nuts. And you know what? There's a lot of nuts in our business, in our fastener industry. And, we just couldn't get by without nuts in this business. And you know what? These nuts have to be good nuts, though. And sometimes nuts aren't that good. And sometimes we don't quite know how to tell if the nut's a good nut or not a good nut. When I come back, I'm going to tell you a few things you need to know about how to tell if a nut is a nut or it's a nut.
Thanks, Carmen. This is Joe Morris with the Fastener Training Institute, and a happy new year, everyone, and welcome to 2021. I hope everyone is ready to get back to training in the new year. We have been busy at the Fastener Training Institute planning new training courses for absolutely all levels of personnel. And in February, FTI will be presenting Fastener Basics with Carmen Vertullo. We're going to be presenting this virtually this year. It's normally a 3-day in-person live class that we're going to be breaking into segments and presenting it over several weeks. The program was designed to teach employees in the fastener industry about the products that they buy, they sell in the warehouse. And while it's intended for people new to the industry, it's really beneficial for all who want to expand their knowledge, and it's great for those who want to cross-train as well. Students are going to learn about what's the difference between a hex cap screw and a hex bolt, and how many different types of nuts are there? What are sockets? What are common materials? Plus, how are you supposed to call out parts in the fastener industry? Plus a whole bunch more. And we really do understand it is tough to sit in front of a computer all day long. So if you can't attend on the actual day or days that we present, we always record these and you have access to the recording. So I hope you can join us. We also have some excellent technical training planned as we partner with the Industrial Fasteners Institute to bring their members-only training to the public. Historically, you'd have to be a member of the IFI to attend any of their training, but now you can access their entire online program through FTI. So please visit our website to see the schedule or just sign up to receive one of our newsletters. Lastly, we are going to have Fastener Training Week live and in person. We're going to have to move our scheduled February date in Cleveland out just a bit, but plan on Houston in March, Cleveland in May. And please reach out to me with any questions, and we always do our best to keep our live class changes to a bare minimum. Our website is www.fastenertraining.com, and my email address is jom@fastenertraining.com. Please reach out with any questions or even just to say hello. Now back to Carmen.
Well, welcome back, everybody. This is Carmen Vertullo with your Fastener Training Minute. I had an email recently, and many of these Fastener Training Minutes come as a result of emails regarding the inspection of internal threads on hex nuts. This particular product happened to be a metric product, and the end user was confused about how to know whether or not the product was conforming when it came to inspecting the threads. Now, hex nuts in the metric world come from a standard called ISO 4032. ISO 4032 leads us to ISO 3269 to tell us what we need to inspect and how to inspect it. Now, it turns out that that is an acceptance inspection plan, which basically means that we're going to have a large sample size based on the lot size, and that plan is going to allow us to have some nonconformances. Unlike what we're used to in the inch world or the imperial world in our ASME standards, which use C=0 inspection plans, which have much smaller sample sizes and allow for zero nonconformances. So what happened is the client, the customer, I should say, end user, inspected a large sample size, much larger than the sample size indicated. And interestingly enough, ISO 3269 does not specify a specific sampling plan. It gives us some examples. It allows the end user or the manufacturer to choose an appropriate one. But in this case, an appropriate one might be 200 would be the number we would check with the go gauge, which is a lot, the go, not go threaded plug gauge, and the unthreaded plain plug gauge to measure the minor diameter. And with 200 pieces, we would accept that lot if we got 4 or fewer nonconformances. That means if we found 4 parts that were bad, we would accept the lot. Well, the customer found 1 or 2 out of 1,000 and they want to reject the lot. And it was very hard to convince them otherwise. Now, as we know in the fastener world, we don't have zero defects. It's only available on certain features and only if we find a way to do a kind of inspection that allows us to look at that feature 100% on every part, which generally means you're doing it with a machine or some kind of a vision system. And we really don't need that except in cases where a robot is handling the part, such as an automotive assembly. We don't, for example, have zero defects with drywall screws. Drywall screw installer picks a screw out. It's got no drive in it. He throws it on the floor and picks another one. It's not the end of the world. You have a screw with no drive in it in the assembly plant of a car, it could shut the line down. So we have reasons for that. Anyway, back to the hex nut. Further, ISO also allows for us to accept product that is non-conforming if the non-conformance does not impair the intended function or use. In this case, this 1 or 2 very minor non-conformances does not affect the function of the part. And the reason we know this is because when we inspect our nuts with the go and no-go thread gauge, the no-go gauge is allowed to enter 2 threads in the ISO world. In the inch world, we're allowed to enter 3 threads according to ASME B1.2. In the metric world, it's 2 threads, and that's from ISO 1502. And that's a little bit subjective because it just says 2 full turns into the not go gauge with no excessive force. Well, they were getting some of them to go more than 2 turns, just those very few. So we know that this is so borderline that it can't possibly affect the intended function. So we present this to the end user, and hopefully they realize that the problem they're causing by not wanting to, first off, use the proper sample size or choose an acceptable sample size, and secondly, not being willing to invoke the ISO 3269 objection clause that allows us to use these non-conforming fasteners if they don't impair the intended function, is not in their best interest. Their line is shut down, whatever it is they're assembling is not going to get assembled. So nuts are one of the easiest things to inspect in terms of threads. It's the go, not go gauge, which in the metric world, 2 threads is allowed for the not go gauge. The go gauge must pass all the way through. The plain plug gauge must not enter any threads. It can go into the chamfer of the nut, but it must not enter any threads. On the not go side, and the go plug must pass all the way through. And that's true also with the ASME V1.2 gauge for the minor diameter for nuts. So once again, it's a nutty world out there right now, and we're getting a lot of nutty questions, and this was one of them. I wanted to share it with you, and I hope you enjoyed this Fastener Training Minute. Thanks for listening.